Hello, we're going to look at exponential functions and their properties, and here is an example of the exponential function f of x is equal to 2 to the x power. And you can see they have a graph for here, and you can check these values. If you put a 0 into there, that's equal to 1. If you put 1 in here, that's 2, and so on. So, and 2 squared is 4, and if you put a negative 1, that's going to be 1/2. You can see it goes through there, and some things happen here. There are no stationary points. It's always going to be changing, right? So it's always going to be increasing. It has a y-axis as a horizontal asymptote. Actually, that should be an x-axis, right? There's a little error right there. And has no vertical. There's no vertical asymptote. It will look like it's going up very, like it might approach a asymptote, but no matter what, as you get over, it keeps getting higher and higher, and you can keep going. So there's no vertical asymptote, and it is injective or one-to-one, meaning it passes the vertical line test. So this is what an exponential function looks like. Let's go ahead and look at some examples. So if we look at example 8, it says the table shows the values for a function of the form y is equal to b times a to the x, where a is greater than 0. Find the values for a and b, and then sketch the graph. So I can use the first thing I want to do with a problem like this is I'll use my initial condition at x equals 0, 3. That'll always help me out with this. I know if I use this, when y is equal to 3, I'm going to have b times a to the 0, and since anything to the 0 power is 1, now I know that I'm going to end up with b is equal to 3, so I've got a value for that. Since b is equal to 3, now I can use any of these other coordinates that I have. So I'm going to go ahead and use the second one. That's the easiest. I got 12 is equal to my b value is 3, and then a to the x power, well, that's 2. Divide by 3, I'm going to get 4, and then a could be equal to plus or minus 2, but I could see, it said that a had to be greater than 0, so a is equal to 2, right? And so on. So now I have all my values, and now I know my equation is y is equal to, my b value was 3 times a to the x, right? And then I can plot a quick graph of what this equals to. When x is equal, I'm sorry, 8, that's supposed to be a 2 in there, my bad. 2 to the x power right over here. Y is equal to 3 times 2 to the x power. Good. And then when x is equal to 0, this is going to be equal to 3. And when it's equal to 1, it's going to be equal to 6. Just like that. And then when it's equal to a negative 1, it's going to be 3/2, so 1.5, right about there, and so on. So you can see it's going to look something like this. It'll never touch this axis, but it'll get really close to it, and it goes like this towards infinity. Sound good? All right, let's look at another example. And this is example 9, and it says, for a well-tempered tuning of an instrument, the interval between the first tone at 440 hertz and the 13th tone at 880 hertz is divided so that the ratio of the two consecutive turns is a constant. What is this ratio? Find the formula for obtaining all the tones of the interval. Well, what's going on here is you have the first tone at 440, right? Then you're going to get the next tone by, it says, by some ratio of 2 consecutive tones. This is sounding like, this is what we call a geometric sequence. So I'm going to have to multiply it by r to get the second one, and then I'd have to do, should be 440 times r squared, and so on. But if I'm going to go all the way to the 13th, actually this should be the way that they should have written this. No, 13th tone, it would have to be the 12th one, right? Because it's the first, second, third, and so on. So I know that 440 r to the 12th term would be the 13th term, and that has to be 880. right? And then I divide by 440, and I get r to the 12th equals 2. And then I can solve this by writing this 2 to the 1/12th, and that gives me the 13th term. Now, I can also, they also wanted me to write a formula for this. I can say use of n is equal to 440, and I found my value to be 2 to the 12th. That's my ratio to the nth power, where n is in the element of 1 to ... all the way to the 11th. And that would give me the 12 terms after it. Sound good? There you go. Last problem we're going to look at is this guy right here, example 10. So it says the diagram shows the graph of f of x equals 2 of x, so that's f of x is 2 to the x, so that's this guy. The graph, and g of x, the reflection of f of x in the y-axis, find g of x, right? Well, if it's a reflection of the f, g of x is going to be equal to f of negative x. That makes you flip the y-axis. And since f is equal to 2x, I know that's 2 to the negative x. Well, that's going to be equal to 2 to the 2 to the negative 1 to the x power. Well, what's that equal to? That's equal to 1/2 x. So I know that g of x is equal to a 1/2 x. And there you go.